Alright class, so we'll be continuing from where we stopped from the other video. So this is the calculation aspect for the physical quantity. So the question said for the first one, we're told to calculate the dimension of angular momentum. So if we are to calculate the dimension from angular momentum, first of all, our angular momentum is equal to our mass when it comes to our momentum when they are in, when it doesn't, first of all, our momentum when it doesn't involve linear or circular motion. When it doesn't, since they are telling us angular, it's already telling us, it's already trying to tell us that they are trying to refer to circular motion. So when it comes to circular motion, our mass in circular motion, our momentum normal when it doesn't involve circular motion is mass times velocity. So when it now involves circular motion, our mass when it comes to circular motion is our moment of inertia times our velocity when it comes to circular motion. Our velocity when it comes to circular motion is our W, which is our angular velocity. So if you are trying to solve this question, very simple. Our I is equal to mr square times our W. Our W is what? Our W, how do you calculate for our W? 2 pi f. So with this, I've gotten the formula to solve my angular momentum. So we're told to find the dimension. So the dimension for mass already, I told you that for all fundamental quantity, the dimension for mass is what? M. So in this case, our length in this case is our arrow, the radius. Anything that has to do with the distance between 2 points is the length they are talking about. So in circular motion, the length is the radius. So it will now be L square times, I told you that any other term at all, any other term that it's not a fundamental quantity in personal, any other term that is not a fundamental quantity in personal, that term, they are referred to as a constant. In order to solve any dimension question, you have to remove all those constants. We remove the constant. That is how it's normally done. So if I remove my constant from here, our 2 and our pi, these are constants, we don't need them. So we'll now be facing our frequency. Our frequency normal, we know our frequency, our f is equal to what? Our 1 over t. So for me, I can get the dimension of my frequency to be t raised to power minus 1 from our normal indices, which you know. So it can be t raised to power minus 1. I've removed my constant. So from there, we'll be left with L square t raised to power minus 1. So this is the dimension of our angular momentum. So let's move to the next question. Let's be fast. So the next question said, a car travels with a speed of 25 meters. per second. So they now ask, what is the speed in miles per area? So we have to convert this one to, convert this guy to what? To miles per hour. So first of all, our 25 mile, we'll convert our 25 mile first of all. Our 25 meter to mile. So if you check your calculator very well, if you check the back, that is for the type of calculator I'm using, in some other lesser calculator or in some other bigger calculator or so, you find out that we don't have any scale or any unit that converts meter to mile, but we have the one that converts kilometer to miles. So definitely we can use the one for kilometer to mile. So how can I convert first of all my meter to kilometer? I will divide by 1000. So if I divide by 1000, dividing this guy by 1000, or rather let me do that here under here. So it will now be 25 divided by 1000. That will give us 0.025 miles. So I've converted it from meter to, I've converted it from meter to what? To kilometer. So after doing this aspect of it, after converting from meter to kilometer, I will now convert our kilometer now to what? Miles. So like I said, you come, you type the value 0.025. Then you type your shift, your convert. So you go to the point where you see a kilometer to mile, that is number 8. Number 8. Then you press equal to sign. At the end, you find out that 0.025 kilometer is equal to 0.0155 miles. So I've gotten that for my miles. Most of the times our calculator doesn't give us the one for seconds to hour, because they know that actually as a 100 level student or as a JAM student or anything you are, you can definitely solve that with your head. So already we know that from our normal from our normal reasoning or from using your head, we already know that 3600 seconds is equal to what? 1 hour. So definitely for this case, I'm trying to convert 1 seconds to hour. So if I want to convert 1 second here to hour, it will now be x, and our x will now be equal to 1 second times 1 hour divided by 3600 seconds. So our seconds will cancel out the seconds. So we'll be left with 1 all over 3600 seconds. Remember, we are converting from meter per seconds to miles per hour. So we have gotten the value for the seconds, 1 divided by 3600. So our x is equal to 1 divided by 3600. The value it gave me 0.000278. So the question said we should find the speed in meter per second. So we have already in meter per hour rather. So we have converted these seconds to hour here, and we have gotten our value for our 25 meter to a value in mile, which is 0.0155. So from there, our speed now be equal to this value 0.0155 mile divided by 0.000278. So if you punch your calculator on that, it will give you 0.0155 divided by bracket answer. So if you punch your calculator on that, you'll be having 55.8 miles per hour. So that is that for that. So let's move to the last question for the day, which I believe is the most technical question there. Yeah. So the question said, assuming that So the question said, assuming that the volume passing through a tube per seconds is given by the equation V is equal to Kn raised to power, rather this is not N, coefficient of viscosity, our mu raised to power x, or let's just call it, okay, any sign you want to call it, let's just call it our sticks raised to power x, our r raised to power y, divided by bracket delta, that is our change in pressure over the length raised to power z. So we're told to find the value of our x, y, and z. So let's solve for that one first before solving for to show that the other part. So if we are to solve for it, we're told that our V is equal to the volume per seconds. The volume per seconds, which is trying to tell you the value for our t. Seconds is trying to tell you the value for, okay, let's use our short t first of all. The volume over the t, our short time, our time rather. So our volume normally is equal to our L raised to power 3. That is the length times breadth times height. Our length, breadth, and height, all of them, they are all distance between points. So they are therefore referred to as the length. So I can just give it our L raised to power 3 divided by our t. This is the fundamental quantity for our t. So I will now say our L over t, L cube raised to power t is equal to, I don't need constants while solving first of all, so I will remove my constant. So take note that let's start by solving for each of these terms first of all before going to jamming the equation together. So our n, our mu first of all is the coefficient of viscosity, which is equal to the tangential stress divided by the velocity gradient. So this is a formula in physics. Coefficient of viscosity is equal to the tangential stress over the velocity gradient. So let's first of all get the value for the dimension for this part. I believe I can clean this part now. So the coefficient of static friction is tangential stress. First of all, our stress is equal to force over area. And we already know that our force is mass times acceleration divided by area. So that will give us m, our big M, representing the mass. Our acceleration from the derived quantity I gave you is equal to L t raised to power minus 2 divided by our area is length times breadth. That is 2 quantity of length, so I can just make it L square. So if you take this guy upward, it will not be minus 2, it will not be m L raised to power 1 minus 2 give us what? Minus 1. So it will not be minus 1 t raised to power what? Minus 2. Remember, I took this guy upward according to indices. So if I take my L raised to power 2 upward, it will not be L raised to power 1 minus 2. So it will give us m L raised to power minus 1 t raised to power minus 2. So that is the value for our stress. Then for our velocity gradient, so for our velocity gradient is equal to the velocity, our V rather, all over. If you look at the question here is trying to tell you, it's trying to talk about a liquid, or rather, it's talking about a liquid placed in a container, something that involves liquid placed in a container. And for that kind of case, I don't think you have to use anything length. That kind of case involves radius. So our velocity gradient is V over R in this case. So our velocity, I told you already, is L t raised to power minus 1 divided by our L. So therefore our velocity gradient is equal to t raised to power what? Minus 1 as the value for it. So if I want to get my coefficient of viscosity now, our mu is therefore equal to our ml raised to power minus 1 t raised to power minus 2 divided by our t raised to power what? Minus 1. So it will now be l raised to power minus 1 t raised to power minus 2. If you take this guy upward, it will turn positive sign plus 1. It will now be m l raised to power minus 1 t raised to power minus 1 as the value for what? Our coefficient of viscosity. So I've gotten the value for that guy. Let me clean this part now. So I've gotten my value for my coefficient of viscosity. So the next step I will now carry out So I just repeated the question so we can have our viewpoint from that part. So I've gotten my value for my coefficient of viscosity now. Our radius we already know that is r. Now r is equal to what? The length. So we don't need that part. Then for the last one, delta P, that is our pressure over our P over L. Our pressure is the same thing as our pressure has the same unit as our stress already, and the formula for the dimension for stress, we have already gotten it from here, which is ml raised to power minus 1 t raised to power minus 2. So I can just come here, ml raised to power minus 1 t raised to power minus 2 divided by our L. So it will now be ml raised to power minus 1. If you take this guy upward, the 1 will turn to minus 1. Minus 1 minus 1 will give us what? Minus what? 2. Then t raised to power what? Minus 2. Remember I said you take this guy upward. The positive 1 will turn negative here. So it will now be minus 1, giving you minus 2. So that is the value for that part. So I've gotten my value for the dimension for our change in pressure. Our change in pressure is the same thing as the pressure because its unit is the same thing as our normal pressure. So we don't need to just change anything from there. So from there, I've gotten the value for that part. So let's continue. Now to find the value for our x, y, and z. So if we are to do it, first of all, we will use our normal value for our volume per cube, volume of tube per seconds. So if you are using our volume of the tube per seconds, this is the dimension for it. M raised to power 0. First of all, there is no mass. Our mass is not present there, so I can make it raised to power 0. Our L raised to power 3 and our T raised to power minus 1. If you take this guy upward, so you now be left with is equal to, I don't need my constant like I just said. I will now go for the coefficient of viscosity. The dimension was this. So it will now be M L raised to power minus 1, T raised to power what? Minus 1, everything raised to power what? X. Then for our Y, L raised to power Y. Then for our delta P, rather our pressure per unit length, it will not be ml raised to power minus 2, which is this value here, T raised to power minus 2, everything raised to power what? Z. So from this case, I will pick my mass from this value, and relate it to the standard in order to get in order to solve this kind of question. So if I'm doing that, our 0 for the mass here, this time we are solving for mass. Our 0 here, our 0 here is equal to no, let's write the 0 last. Let's write for this one. Our mass here is equal to m raised to power x. So our x, we have to pick just the powers. So the mass here is raised to power 1. 1 times x will give you x. So our x here, the mass here is equal to 0, so we don't need the mass. So for this part, our mass here is raised to the mass here is m raised to power z, because our mass is raised to power 1 here. So it will now be plus z is equal to the mass here is what? 0. So for our L is minus x. Our L is what? Plus y. And our z is what? Minus 2z is equal to what? 3. Then for our t, we have minus x, and our t here is raised to power 0. So our t here is what? Minus 2z is equal to what? Minus 1. So can I clean this part? Yes. So if I'll clean this part, let's continue from under this part so you get it. I want to get my value for x, y, and z here. I can say my x is equal to minus z, but if you take this guy to the other part, it will give you minus z. Anywhere I see x, I'll place minus z. If I place minus z there, the minus sign will affect this minus sign here and it will turn plus. We'll now be having z minus 2z is equal to what? Minus 1. Definitely our z minus 2z will give you minus z is equal to what? Minus 1. The minus will cancel out the minus, and our z is equal to what? 1. So after getting that, we are just left with the value of y. I have my okay, we haven't gotten the value for x rather also. So I can say since our z is equal to 1, I'll place it into equation, into this part. I'll now have my x is equal to what? Minus 1. Then I'll come to this equation, this one here. Anywhere I see x, I'll place minus 1. So minus bracket minus 1 plus y minus 2 bracket. What is my z value? 1 is equal to what? 3. Minus times minus will give you plus, so it will be 1 plus y minus 2 equal to what? 3. So it will be y 1 minus 2 give us what? Minus 1 is equal to 3. So our y is now equal to 3 plus 1. So our y value is equal to 4. So definitely I've gotten my value for x, y, and z. My x is equal to minus 1. My z is equal to what? 1. And my y is equal to what? 4. So those are the three values. I remember that our v is equal to k coefficient of viscosity raised to power x, arrow raised to power y, and our delta p over L raised to power what? Z. So I want to prove this equation here. So if I'm trying to prove it, I'll now place my value for my x on top of this part, and this part. So I will now be having our v is equal to k. This time you introduce your constant because we are trying to get the actual formula. So it will now be k mu raised to power. What is my value of x? Minus 1. My arrow is what? Arrow raised to power y is what? Arrow raised to power 4 bracket delta p over L raised to power what? 1. So we don't need to write that one there. Let me clean the top part. So after writing this one already, I want to represent it in this form. This is the same thing as it. I can say our v is equal to our k coefficient of viscosity raised to power minus 1, arrow raised to power 4, delta p over L. Therefore, our v is equal to, if I take this guy downward based on his minus 1, if I take it downward, it will now be k arrow raised to power 4 delta p all over coefficient of viscosity times the L. This already shows us that this value is equal to this value. So I have successfully proved that part of the equation. So that is that under the calculation aspect for physical quantity. So if you have any question at all, you can just simply tag it on the comment section and wait for my next video. And if possible, the next video I'll be releasing, I will therefore solve that your question that you throw on us. And remember, this is the exclusive tutorial.